Hi everyone, it's Alicia with Connect Core Math, and I'm going to show you how I use Math Labs both in the classroom and for distance learning. I just finished teaching remotely summer school, Integrated Math 1. We use the Canvas platform instead of Google Classroom. I typically have used Google Classroom in the past. Canvas is more expensive, but it offers a lot of perks. And I did a Zoom meeting every morning, and then my students had time to finish things basically on their own time afterwards. But looking at a model that is synchronous or asynchronous in terms of can everyone get on at the same time? And if we're in a hybrid model, it's going to be nearly impossible because students have different courses and demands and for Wi-Fi devices, all of that. So when they are offline, you're probably going to want to make a short video for your lessons. And that's kind of what I'm going to show you right now. And how you can, I'm using an HP Pavilion, it's less than $600 laptop with its touch screen. So I can write on my screen, for example. Let me just go ahead and do that now and share my screen. There's in Zoom an annotate button. And so there's a little heart there. So you have shapes, stamps. I can draw figures. It helps me when I'm plotting points for doing these nice and perfect, circles and whatnot. There's not like a ton of shapes, but the point is, you have breakout rooms in Zoom, you have annotate PDFs in Zoom, you can record like I'm doing in Zoom and then post this as a 5-minute startup. You want to make it less than 5 minutes because you want the kids to just be able to get started on it and then work on it. Just as if you were in class with them working collaboratively, they would obviously still need to kind of get started with you, and then they could break off into their partners or their groups, and then you could come back as a whole group. That model can still be used. It just looks a little bit different. For example, I do a discussion question after the students submit their lab to me, and they answer a question, and it's part of Canvas. It's nice. It's like a Facebook thread. And then they can't see anyone else's response until they respond. And it usually can be like, what was your conjecture for slope, and or it could be a critique where you critique the reasoning of whoever you're writing a problem about, or their conclusion of the lab. And then after they're done posting that, they basically will have to read 2 others and comment on it. And so that is one thing that you can do that kind of incorporates a collaborative element to this, because we have to make the best of COVID, and it's not ideal, but this can work. These are guided labs, so you can have students still engaging in exploratory math that is good for them, that they can visually see and come to a conclusion, noticing patterns, making conjectures, critiquing, all the things we want them to do as young mathematicians. So let's get started. I like the eraser feature on here. I could undo everything, or I can just erase it and then it's gone. So I bought a stylus, so I'm using my touch screen to write on this PDF. You can buy a thin one on Amazon, and the thinner ones help you to write a little bit neater. So pardon my handwriting if it's not that neat. So I typically would start the video like this. Good morning, everyone. Today we're going to be exploring 1.3, which is titled Baby, It's Cold Outside. And the question that we're going to explore is, how do you add integers such as case A, which is right here, -24 plus 4, or case B, which is right here, -2 plus -3. Go ahead and write down a hypothesis like you've done in the past, like we've done in class. And it's okay if it's wrong. They're just making a prediction using maybe some prior mathematical knowledge to help you come up with a hypothesis, or maybe just taking a stab at it. And it's okay if it's wrong. Teacher to you, teacher to teacher now. students might pause the video and make their hypothesis or not. So I'm not going to write anything right now. So case A, you know, they might write, I think the answer is -28, for example. And for case B, they might say, I think the answer is -5, whatever it might be. All right, now let's start the lab. Directions, we're going to use 2 color counters to solve each problem using one side to represent a -1 and the other side a +1. Draw a quick sketch and circle 0 pairs, because those are going to just cancel out to 0. Let every positive represent 1 degree Fahrenheit. Remember the difference between dropping degrees and rising. So they need to know you drop degrees, you're subtracting. When you are rising, you're adding degrees, etc. So let's do number 1 and 6, and then you guys can go ahead and put your answers as usual in your handy dandy table here. With the problem and the sum, column A and B. So we have 1 through 5 and 6 through 10, so that you can notice, make a conjecture, test your idea, and critique the reasoning of others. After your discussion question, you have 1 independent practice page of 5 problems. Okay? All right, so let's get started here with number 1. It says the temperature was a freezing -6 degrees Fahrenheit and then rose 2 degrees Fahrenheit. What is the temperature now? So as you can see, there are 6 current negatives because there is currently, it's -6. So there's 1 here, 2, 3, 4, 5, 6. And then it says, then it rose 2. So it added 2 degrees. So these 2 are positive. 1, 2. So when you guys draw these, you can just go ahead and, you know, draw your circle and then put in, whoops, put in a plus or a minus sign in the middle just to represent positive or negative. Okay. All right. So I'm going to circle the 0 pair, which it's already done for you here, the first one, this one, so that's 0. And then I'm going to circle this one, and that's 0. And so I'm left with, over here, -1, -2, -3, -4. So I'm just going to go ahead and write that here. And then I'll record this number sentence problem and the sum in the table, because the problem was -6 plus 2, and we found the answer to be -4. Now for number 6, it says on Monday the temperature was -4. So I'm going to go ahead and draw my -4. So -1, 2, 3, 4. And I'm just going to go ahead and make sure that I just put like a little negative in there. And then it says on Tuesday it dropped another. So it dropped another 3 degrees. So we're going to add 3 more negatives. 1, 2, and 3. And I'm going to make sure that those are negative. And then the problem is -4 plus -3, and there's no 0 pairs. So I'm just going to count. I have -1, 2, 3, 4, 5, 6, 7. And then you're going to put your answers in a table, and hopefully, mathematicians, you will notice a pattern when you add integers that have the same sign, like case B, or where one is negative and one is positive, like case A. All right, happy exploring, you guys. Take care. And so that's kind of how I would make my videos. Short, sweet, sign them off. Reiterate the assignment again is to do the lab, answer the discussion question, finish the independent practice page. And that's the same thing they do in class, so that when they leave, they know what to do. This lab process shouldn't be foreign to them where they're confused. They should be like, okay, we're doing a lab today. I know how to do this. I'm putting on my think like a mathematician cap and going at it. So hopefully this helps you. I'm bouncing an idea off that worked for me, but you might have other plans. Again, if you can get kids all to be online at the same time without causing inequities, and have them go into a breakout room and have them actually explore this together and complete the lab together, and then come back whole group, if that's possible, great. I think that's probably only possible in a physical, you know, brick and mortar old school building, right? Where we hopefully will be back to soon But in the meantime, if we cannot do that, then I think a quick 5-minute video for the lesson, and then pushing that out to, you know, whatever you use, whether it be Google Classroom, Schoology, Canvas. There's so many distance learning platforms, but whatever you use, the goal should be to have students exploring math visually and thinking like a mathematician, making conjectures. And that's what this program is about. So I hope that it can fit into your distance learning program easily. The graphing units, my students still use Desmos to help them, and then they sketch it. My students upload their work. So these are PDFs. They can print them at home, but if you see your students once or twice a week, you can have that weekly packet printed, or you can order my books, which I think are better, and then the student just takes a picture of the lab and then they upload it to Canvas, and it's super easy. My daughter is a 10th grader, and she took summer school this summer and took chemistry, but she just commented how easy it was to navigate on Canvas and to upload her work. So if students don't have printers, you know, you want to be able to provide these PDFs printed out for them. But also, if it's easier for them to have this lab book because they work in it, then when they come back to you, you can walk through and make sure that they completed it. And also their discussion question on the platform will be completed. And I think you can do something like that in Google Classroom too. So anyways, I hope this helped. Take care, guys. Bye.